All right, guys. So today's video is the start of chapter 10. So we're going to be looking at 10.1 and 10.2. And chapter 10 is all about area. So we'll be looking at area of different shapes and how we can go about those using different things that we have already learned. So 10.1 to start off with is specifically over the area of parallelograms and triangles. So, kind of starting with the basics, and this is going to feel like probably a little bit of a review. The area of a rectangle is specifically base times height. All right, so the height is always going to be creating a right angle with the base. So, in this problem, we have the base here, the height here. All right, so that's how we find the area of a rectangle, base times height. It's the same way you find the area with a parallelogram. Parallelogram also has an area of base times height, where again, the height always has to create a right angle with the base. So this right here, where I just labeled to be the height, and then the base is the bottom there. And then last but not least, the area of a triangle is 1/2 base times height. So those are the three area equations you're going to need for 10.1. None of this should honestly be too new for you because you guys should already know the area equations for a rectangle and triangle and whatnot. But just kind of a refresher, these are the different area equations for the following. First thing that we're going to do real quick, just to make sure we have this part down, because the most common mistake made in these problems is understanding the difference between the height and what's not the height. So if we look at these two problems below here, we have specifically in number 1, a parallelogram. And the altitude is another name for the height. So there's a couple ways where you can see the altitude in a parallelogram. One is like you see above, where it's just extended like so, and again, it's creating a right angle with the base. Sometimes, though, you might see it outside of the parallelogram. So you might see something like this, where it extends outside, and this could be the height as well. Both of these would be options for the height. You just have to be able to figure out which is which. Okay. This extended part has nothing to do with the base. It's just there to show you where the height is coming from. Same idea with your triangle. So with your triangle, it could be straight from the vertex down to your base, like so, or you might see it outside of the triangle. So you might see something kind of like this, where it extends down like that, and there's your height. The key thing that you have to understand here is the height always creates a right angle with your base. If it is not creating a right angle, then it is not your height. It's got to create that right angle. Okay, that's super important here. So that is the couple different ways where you could see the height. Now we're going to do just a couple quick example problems. Nothing too crazy, just to kind of get the general idea. So for this first example 3, we're finding the area of the parallelogram, which we know area of a parallelogram is specifically, base times height. So what we want to do here to get our area is we want to take the base. Your base is right here, and you want to take your height. Your height is this 4. Don't let this 4.5 confuse you. You don't even use that. All you need is the 5 and the 4. So your area is that 5 for your base times 4, which is your height. So your area will be 20 inches squared. Yes, you should put the units. Okay. And then we also have an example with the triangle here, where we're finding the area of this triangle. So the area of a triangle, as we know from above, is 1/2 base times height. So here, your base is this 3, and your height is the 4, because those are the two sides creating this right angle here. And once again, they try to give you this 5 to confuse you. You don't even use it. You just use the 4 and the 3. So your area is 1/2 the base, which is 3, times your height, which is 4. So 1/2 of 3 times 4 is just 6. And there's no units, so you'll just put units squared. Okay? So again, just a couple basic area problems. But that's how you would find the area of that triangle and parallelogram. The last problem we're going to look at with 10(1) before we look at 10(2) is the following here. So what we have is we're going to find the area of this parallelogram ABC, and we're going to find DE to the nearest tenth for ABC as well. And we're going to use the fact that FC is just one of the two heights of this triangle. So FC is one height right here, which is 9, and then the other height is this DE. So we're going to be working backwards a little bit. So first we want to find the area using this area equation of base times height. And this 9 is one of our heights. What we need to do is we need to get the base that goes with the 9. So remember, the base and the height have to create a right angle with each other. So if you look, here's your right angle, which means the base that you're going to use with this 9 is the 13. So we can get our area by taking 13 times 9, which specifically is 117 inches squared. So there's the area. Now what we want to find is this height DE, that H there. So we're going to use our area that we just found. So we're going to still use this problem. We're going to use the fact that we know the area is 117, and we need to get the base that goes with this height that we're trying to find here. Well, here's your right angle. That goes with this base. So our base is 9.4 times our height. So to get the height, we need to divide both sides by 9.4. When we do that, you get the height of DE to be 12.4 inches. That's your distance of DE. So it's working backwards a little bit. It's using some problem solving here. So this is kind of a different problem compared to the other ones, but it just uses tools that you already have. All right, so now let's look at 10(2). 10(2) is more area. Specifically for these, 10(2) is over the area of trapezoids, rhombuses, or rhombi is actually what that should be, and kites. So we're going to first look at the area of a trapezoid. The area of a trapezoid is kind of a different one. This equation is interesting, but the way you find the area of a trapezoid is you take 1/2 times the height. So it's kind of looking like a triangle so far, but then you have to add the two bases together. So base 1 times base 2. So that's the area of a trapezoid. So to see an example, we're going to find the area of Nevada here because it's kind of shaped like a trapezoid. So we're going to take the area of 1/2. Our height is this 309. And our two bases, so we've got one base here and one base here. So the 511 and the 205. So we want to add those together. So then from there, sorry, that's a 5. Could probably make that a little better. So we got 205 plus 511. There we go. We want to add those together. So then the area ends up being 1/2 that 309. When you add your bases, you get 716. And then when you put it all together, you get your area to be 110,622 miles squared. So that's how you would do a problem like that when you're finding the area of a trapezoid. Okay. Now we're going to look at how to find the area of a kite or a rhombus, because the area equation for both of those is actually the same. So the area of a kite and a rhombus can both be found by taking 1/2 times the two diagonals. So diagonal 1 times diagonal 2. Couple things to remember that are going to help us out with these problems is when you have specifically a rhombus, you need to remember the diagonals are perpendicular bisectors of each other, which is actually true of both. So both of these create right angles when their diagonals bisect. And for a kite, remember the shorter diagonal is bisected by the longer diagonal, and they're also perpendicular. So just to kind of give you an idea of how you would go about these problems is you would take the two diagonals, multiply them together, and divide by 1/2. So for 2, our area is 1/2. Now, it's kind of hard to tell, but this is 5. So that means this has to be 5. And this is 3, so this has to be 3. So your diagonals are 10 and 6. So you want to do 1/2, 10 times 6, and what you end up with is 30 feet squared. Same idea over here for the kite. So these are both 10, and then this one is 20, and this one is 10. So one of your diagonals is the 10 plus 10, which is 20. The other is the 10 plus 20, which is 30. So then your area is 1/2 of 20 times 30, which ends up being 300 meters squared. So you just add the two parts together to get the diagonals. So I did 10 plus 10 to get the 20, and then 10 plus 20 to get the 30. And that's it. So that's all for the first part of chapter. Oh, that was weird. I don't do that. Sorry. So that is the first part of chapter 10. When I see you in class next time, we're going to do some more examples over these. But again, hopefully just this felt like quite a bit of review over area. Yeah, so that's all. Enjoy the rest of your day, guys. Bye.